In this video, we'll go through the process of downloading and importing a new PDB file into our VR simulation. So starting in the main folder, we'll go to Simulation folder, and then PDB Files. This is where our PDB files are stored. And then there's an additional folder, EEM Charges. This is where we can store pre-computed electrical charges to help increase the quality of the simulation. This is still in testing though. So we'll open up the web and we'll go to rcsb.org. So there's probably many places where you can download PDB files, but this is one place that we use. So we'll go and find a PDB file. We'll go to Download Files and choose PDB Format. And then that will appear in our downloads. And then an additional step that we can do to help increase the quality of the simulation is we can go to this website, Atomic Charge Calculator 2. So this is a GitHub-based project that pre-computes the electrical charge for molecules. So we can choose a file and click the one we just downloaded. And if you click Compute Charges, it'll use recommended settings. But if you're importing many molecules into VR, it might be good to use the same method for all of your files to have more consistent results. So we'll go to Setup Computation so that we can manually choose the method. And now that the file's been uploaded, we can see the various methods for this file. We've been using EEM, and then you can see different parameter sets. We've been using this parameter set right here. And then we can go and add to calculation, and then click Compute. Now we can see a preview of the molecule. For example, here is the surface charge. But what we want to do is go to the bottom and click Download Charges. And then we can go to the download and unzip. And then in this folder, there's many subfolders. We'll go to the txt folder. And then currently, we want to rename the file to resemble the PDB file name. So we'll rename it to 7tff.pdb.txt. And we'll just copy this over to here, and we can close this. And then what we want to do is I'll go and copy this one and paste it into this folder. And then I'll take the text file which has the charge information and copy that into the EEM charges folder. Our simulation system is looking for matching file names, so that's why we renamed it as such. So now we can go to simulationinput.exe and open that. And currently our PDB file configuration is still in a text file format. But we've made this page to help you get an idea of how to format that text. So we can go and copy the name of the PDB file we just downloaded and paste it in here. And then there's various settings such as center the object, use original location, or we could use location offsets and rotation offsets, or we could scale the PDB object. So we'll leave those as defaults for now. And then we can click Load PDB File. And then after it's finished loading, we can see the dimensions of the molecule in Armstrongs, the object's bounds, and the PDB's center with relation to 0. And then this picture shows the representation of the axes of our simulation. So x is horizontal, z is depth, and y is vertical. And then you can also see the rotation. The arrow is in the direction of positive rotation. So it's pre-generated the text format that we need to load the PDB file. So we don't need this quite yet, but we can copy it. And then we'll go over to the Advanced tab. And then within the File Settings section, we can see a drop-down, Selected PDB Configuration File. So here there's many different configuration files that have already been created. But what we want to do right now is create a new PDB configuration file. So we'll enter a name. So for this, I just named it the PDB files name and test. And then we'll save a new PDB configuration file. And now it's telling us that the configuration file has been created, and we need to go to this folder to edit it. So we'll go into PDB files, configuration files, and then here is the text file that was just generated. So the top of this file gives information on how to configure this manually, but we used the GUI, so we can just go down to here and paste in what we copied from this VR objects page. So this text down here, except it was for our different file. So right here, P stands for path. So the path is pdb files /7tff.pdb, and then the type is pdb, the count is 1, currently no flags are set, the scale is 1, and location and rotation are all at 0. And then we can delete the extra one. And it's recommended to maybe give a descriptive name right here. So we can go to where we got the file, and we'll just copy this explanation right here and paste it there. Next we can save this file. So I'll do Control S and save it. And then we can close this file. So now this file has the information about our newly downloaded PDB file. And then we'll go back to the Advanced tab. And now we can select our new configuration file that we made. And then click the Save button. Now before we start the VR simulation, there's one more thing that we should check. So we'll go over to the VR Objects tab, and we'll type in the PDB file that we just loaded. So and then click Load PDB. And after it loads, we want to check the dimensions. So it says it's 90 by about 130 by about 144. So we want to make sure our simulation space is large enough to hold this molecule. With that in mind, we'll go over to the Primary tab, and we'll just make the Y and Z larger. So 200 should be good. And then for the loose particles, which is solution, we'll just set based on simulation space. And then we'll click Save. And now we should be ready to launch the application. So we'll go back and now find vrsimulation.exe and click that. And click OK. And now P to unpause. And now we can see the molecule that we loaded. So maybe one thing is this molecule is fairly large, so it's hard to move by the mouse. So if we click M for menu, we can switch to a different menu, and then we can go to grab mode, which is set to velocity, which is a stronger mode, but we want to increase its strength even further. So maybe 0.4. Now it's a little bit easier to manipulate the orientation of the molecule. We can increase it even more to get more power. So now it's fairly easy to rotate it.